अब स्टूडेंट्स कुछ बात करेंगे अबाउट द फ्रेम साइज. Students, why do we create multiple chunks of data? Why do we create small sized frames? Why do we break up the data into smaller frames at the data link control sublayer? Why can't we use a big frame? Why can't we use one big frame, dump all the information in it, and then pack it up and everything, and then send it from the sender to the receiver? That would be much easier, isn't it? Rather than creating multiple chunks or multiple frames at the sender's data link control sublayer, and then you use the destination's data link control sublayer to actually regroup all those packets before we supply that data back to the network layer. Why do that? Why do the chunking? Students, we can very well create a big frame and we can dump all the data in it. The problem with that is even if we have a 1-bit error, हम लोगों ने एरर डिटेक्शन और करेक्शन की डिस्कशन में बिट एरर्स और बर्स्ट एरर्स की बात की थी. If you have got a big frame, even if you have a 1-bit error, that 1-bit error can actually discard or force you to discard the whole frame. You may need to get this whole frame retransmitted from the sender end, even if there is a 1-bit error. We'll go into the details of that, but for now you need to know that the reason we divide the data that we receive from layer 3 in the form of packets into these small chunks called frames at the data link control sublayer, the main reason for that is so that when an error occurs to one of our frames, we only need to discard that one frame, or we only need to get that one frame retransmitted from the sending end. If you have got a big frame with all that data stuffed into it, then you will need to go back to the receiver, and if your data is in a situation where it's being discarded, it's error prone, and so you can't recover it at the receiving end, then you'll need to go back at the sender and you'll need to sort of create that whole frame once again, allocate the bandwidth and do whatnot to actually get that whole frame of data back from the sender so that you can receive it at the destination. Students, when it comes to frame sizes, frames can be divided into two categories based on sizes. Frames can be fixed in size, or frames can be variable in size. Students, when the frames are fixed in size, which is seldom the case in our local area networks and wide area networks, the size of the frame, it actually acts as a boundary or a delimiter. What do I mean by that? Students, when you have got a certain size frame, let's suppose you have got a 16-bit frame. You've got a frame that consists of 8 bytes. All your frames, doesn't matter whether you're sending thousands or millions of bytes of information, the agreement between the sender or the source and the destination is that the frames are going to be sent in 16 bits each. Every frame will be of a fixed size. Students, in this particular case, we don't need to add all the other small pieces of information or overhead to actually protect that particular frame from error in some cases and flags and so on and so forth. And you will understand that part. Students, when that happens, all the receiver needs to look into carefully is that the exact 16 bits are received before it expects a new frame. New frame starts coming in, 16 bits, it expects a new frame. Students, the problem with fixed size chunking or problem with the fixed size framing is that quite a bit of the error control, error detection and error correction mechanisms and the flow control and all the techniques that we are going to be talking about in this particular case that we will still need in one way, shape or form or the other in a data communication system, they become very difficult to apply to a fixed size frame. Students, because of that reason, and we'll elaborate on this particular point further, but because of that reason, most of our framing exercise that we do in data communication systems, especially in the case of local area networks and wide area networks, is variable in size. Framing is variable, frame size is variable. Students, in the case of variable size frames, the question that is very important is how do we define the beginning and end of a frame? Fixed size frames में थे तो हम लोगों ने ये देखा था कि मैंने आपको बताया कि the number of bits that make up a frame that acts as a boundary or a delimiter. if our frames are variable in this particular case, then how would we deal with it? Students, slide pe dekhiega. In this case, you have got the variable framing techniques, and there are two basic techniques that we are going to be talking about in the future discussions. The first technique is the connection-oriented framing, and the second one is the bit-oriented framing. Students, connection-oriented framing को हम लोग byte-oriented framing भी बोलते हैं, and byte-oriented framing. Or students, we will carry on with this discussion of the variable framing techniques in our next topics, and I'll explain to you further as to why this is called the byte-oriented and why the second type is called the bit-oriented framing.